Alright people, good day. We're going to try to learn completing the squares. Alright, but why I didn't do a YouTube video is because I noticed that the YouTube videos they make things more complicated than they need to be. Alright, so let's try to keep it as simple as possible. So we're doing completing the squares, right? Right, and there's a general formula for quadratic equations. Remember, we do completing the squares whenever we're given quadratic formulas. You remember this formula here, right? Please excuse my spoon. So that's ax squared plus bx and c, right? So you know that a is the number that is in front of x squared, b is whatever number is in front of x, and c is a constant. You don't have any x value, it's just a whole number by itself, right? Good. So that is the general form of any quadratic function, right? When you come on to the vertex function now, you can use the vertex function to deal with completing the squares, and here is the vertex function. Here's what it looks like. Right, essentially you are going to create a bracket. Really, you have a open bracket x minus h, and that's x minus h squared plus k. All right, and we're going to go further now into what all that is supposed to mean. All right, good. Now we notice we have h, right? We have a h in the formula, and there's a formula for finding h, right? It's not as complicated as it sounds, right? So basically what you do now is you look for b, whatever the b term will be in the general equation that you're given, and you look for the a term also, right? And you basically substitute them into the equation, and it's the same idea when you're finding k. The formula for k, some of you who have used the quadratic formula already, you might be familiar with that pattern right there, right? It's the same pattern, right? So you know that's b squared now, so we're finding the b, the number that is in front of x alone, and we're going to be using a, the number that is in front of x squared, and we're going to be using c, right? We're going to need all of that to find k, right? So what does all that look like now? Right, so we're going to be doing an example right now, right? So here is a general example. They've given you this function right here. Good. So first things we do, we identify the a, b, and c. Remember, as we were talking about previously, the number in front of the x squared is the a term. The number that is in front of the x is the b term, and the number by itself without any x, that's a constant, right? Good. Now in this form now we're going to basically find what h is by itself and find out what k is by itself, and we're going to plug it into the formula. All right, now what does that look like? It's going to be a bit hoppy and steppy, but it can be done. All right, and I use these numbers up here. These numbers were chosen just because, you know, it can get nastier than that, but just to keep it simple, just to find out the steps. All right, moving forward. So we need three things, right? We need the original quadratic equation. We also need to know the vertex formula, right? And then we need to know how to calculate h, and we also need to know how to calculate k, right? So in using the vertex formula, three things must be known. We need to know the original quadratic formula, we need to know the vertex formula, and we also need to understand how to find h, and we also need to understand how to find k, right? So let's go through that now one step at a time. Good. So we have h. right? What is B? How will you look for B? See B up here in the original formula, and we just substitute in B right there. Good. So what about A? Where did A come from? A came from the formula. So we just look for what A is, and we substitute it in right there in the formula. So A is 3. So we just put in the formula, and from there on out, it's just simple fractions. 6 over 2 times 3, that's 6. So H ends up becoming 1. Right? Clear as mud? Alright. When it comes down to working, sorry for that, as we were. When it comes to working with K now, right, it's the same substitution. All we need to know is where do we find that stuff? Where do we find B? Where do we find A? Where do we find A? Same place up here. The numbers in front of x squared and the numbers in front of x, right? So we just plug them in down here. So we plug them in down here, right? We plug them in down here, and no, this is not a mistake. That is C. That's 4AC, right? And so the value for C, it's up here. So we just plug that into the equation. And this is what it looks like. Right? When we plug in all those things, the B squared and the 4AC and the 4A down here, that's what it looks like. Right? And simplifying, we end up with this answer. So K is equal to 2. Alright, now basically all we have to do is to substitute in the values that we've got for H and K, right? All we have to do is substitute in those values into this equation. Right? All we have to do is substitute in those values into the equation. And remember, there was a general form of the equation. This is the vertex form, right? So all we do now, we just substitute in K and H. So these values that we got here, H equal 1 and the 2 equal K, we're just going to put them into this formula, right? And this is what it looks like. See the number that was in front? See it here, so the formula, you see A was right there, right? And what was A? A was 3 up here. So we carry back the 3, come down here. You see that? What is H? We calculate out H to be 1, right? So we put back the 1 there, inside the bracket right there. See that? We calculated the K to be 2. Calculate the K to be 2 out there. And what do? We put back the 2 there. Right? So you just substitute it in the formula. Alright? So please let me know if that helped. Let me know what could be changed to make it clear. Alright? I just noticed that the ones that they were putting on the internet and YouTube, they're a bit difficult, even for me to understand as a teacher, because they're going into a whole bunch of stuff which is, I don't know, it just look extra. Right? Right, and the more things, the more steps you need to remember, the more difficult it will be. Alright, so try this and let us know what's happening. Alright, good.